Hey, solve this thing right here.
Whoa, hey, that's another rational expression, but this time we're adding.
So should we get a common denominator?
I'm thinking common denominator.
So our common denominator would be x plus 3, x minus 1, which, because that's what each of these are, so we would have to multiply the first fraction by an x minus 1 and the second one by an x plus 3. Or are we going to just completely get rid of the fractions here?
I actually don't mind, whatever. However you want to go,
What I was
I'll be
thinking
supportive.
was that, like...
Don't do that, though. No, I'm just kidding.
Yeah, hang on. One sec. It'll be more than a second.
2 minutes?
Distribute here. 5x minus 5. And then
3x plus 3.
Plus 9?
Plus
Can we
9,
distribute?
yes. That's what I said.
So 5x plus 3x is 8x. Negative 5 plus 9 is positive 4. We could factor out a 4 here. It's not really necessarily going to help us out much.
No, but it's
you know,
it's doable.
Yeah. So now this is going to help us out as far as our sign chart goes.
And now that we've got everything how we need it, we can figure out what our zeros are and our undefined.
Right, so our zeros are where the top equals 0, so that'll be x equals negative 1/2, because you subtract the 1 over and divide by 2. Our vertical asymptotes down here will be
negative 3 and positive 1.
So that's what's going to go in our sign chart.
Sign away, baby.
So we really don't need that 4 whenever we do this.
The 4 doesn't make any change in the sign at all.
If we had a negative out there, that would matter, right?
Yeah, negative 4 would, yes.
But if it's positive, it doesn't matter. If we had a negative 4, we could just probably like throw it down here at the bottom or something.
I guess we could throw it up.
Yes, throw it down at the bottom. Throw down at the bottom. So remember, we put our zeros and our vertical asymptotes. Negative 3, negative 1/2.
And 1.
1.
And remember, we're only interested in whether the sign of the whole thing is positive or negative, not the actual number of the thing.
Right. True that.
True that indeed.
Okay, so negative 4 we plug in, and that'll give us a negative.
Negative and negative. Hey, there's that whole odd negative thing there, by the way.
Oh, so that'll be negative.
Yeah.
Negative 1, that'll be negative 2 plus 1, which is a negative.
Then
that'll
positive,
be a positive.
and then negative.
Negative. So that's an even number of negatives,
hey,
so that's positive.
wow, we're using a cool trick here.
0 plus minus.
Negativo.
And then 2
should be
positive.
I'll be pluses. I'll be pluses.
So that's positive. So it wants, you have to look back here, because at this point you might have been saying, what does it want? Positive, negative?
Yeah, it just wants negative only.
It wants negative only because it wants it to be less than. So we're negative here from negative infinity to negative 3, and from negative 1/2 to 1. So negative infinity to negative 3, not including negative 3 because it's not equal to, and then negative 1/2 to 1.
Perfect. Amazing.
Yay.
Actually.